Okay, where were we? Yeah, let's come back now to two dimensions. And the spacing of galaxies along the x-axis and the y-axis and grid size is the same. What's the distance between two galaxies separated by distance delta x along the x-axis and delta y along the y-axis? If shoot at it, this is square root of Pythagorean theorem. First of all, what's the distance along the x-axis? It's a times delta x. The distance along the y-axis, in other words, the two galaxies went over here and over here. The distance along the x-axis is a times delta x. The distance along the y-axis is a times delta y. And then using the Pythagorean theorem, the distance between them is just d is equal to the square root of delta x squared times a squared plus delta y squared times a squared. And now we can factor the a squared out of the square root. Again, as Michael says, it's just proportional to a. It's proportional to a, the distance. And now instead of just simply delta x, it's the square root of delta x squared plus delta y squared. What would happen if it was a third dimension? Plus delta z squared. That's a three-dimensional Pythagoras theorem. Okay, that's the distance. What's the velocity between these 2 points? One over here and one over here. It's just the time derivative of this. Alright? So the velocity is given by the same square root, which I won't bother to write, times the time derivative of a. E dot. That's the velocity of recession. And now we just multiply it and divide it by a. Over a. Same trick as before. And recognize that a times the square root is just the distance. So we get exactly the same formula as before. Distance times Hubble constant. The Hubble constant doesn't depend on direction, it doesn't depend on where you are, but it does depend on time. In general, it may depend on time. Velocity equals distance times Hubble constant, and it doesn't depend on the dimensionality of space. Okay, that's the Hubble law.